Okay guys, so we're going to start with a simple problem about mole-to-mole calculations. So those are the ones where you're given a set of moles and you have to then convert it to another set of moles using a balanced equation. So we won't worry about balancing it right now since that's a different lesson, but I do want to show you first the generic setting here and then how to go from that to the actual problem. So we'll start off with the generic, which is going to be moles of A, okay, multiplied by our conversion factor of moles of B on top and moles of A on bottom, because we're trying to get rid of that. This is what we call the mole ratio. And the mole ratio comes from the equation. Okay? So we're going to start off by giving you an arbitrary number, so it doesn't have to be anything that you know specifically. So we're going to say that we have 6.4 moles of iron sulfide. That's FeS. Okay? We want to change that into and find out how much will react to give us the product of iron 2 oxide, iron 3 oxide, excuse me. So that would be 2 moles of Fe2O3. So notice how I didn't put the 2 from up here yet, because I'm not actually using that. This is just what I want to know, so we're going to leave that as a blank, and I want to know this. So using the generic setup, at this point I just write down what I have. So this would be my A, okay, and this is my B. So given that, let's set it up. So that would be 6.4 moles of FeS, okay, and that is going to be set up with a conversion factor of moles of B on top and moles of A on bottom, because we're trying to get rid of that. So this should be on the bottom. So I don't use this number again. I now have to go to the equation and get the ratio out. So this ratio from A to B is going to be, that we're using, that's going to be 4 moles of FeS is equal to 2 moles of Fe2O3. Okay? So when you get a problem like this, these simple kind, you don't need to go to the periodic table and find the molar masses. All you need to do is use the ratio given from the equation. So I got these numbers from up here. Okay? And so using that, now we can go and figure, all right, well, let's put it where we want. So we're trying to get rid of this, so this has to go on the bottom. So there should be 4 mole of FeS. And this on top should be what we're trying to get to, which is going to be our 2 moles of Fe2O3, because that's what usually comes out of the equation. So that should be 2 moles of Fe2O3. So again, the equations themselves, the chemical formulas, tend to not be important here. What matters is that you know the ratio from up there and how to use that. So from here, you would then do the math. Now that would mean 6.4 gets multiplied by 2 and then divided by 4. And using that, we can calculate our answer. So if you want to pause it and then figure that out, but once you plug it into the calculator, that should equal to 6.4 times 2 divided by 4. I got an answer of, I believe, 3.2. And now my unit should now be in moles of Fe2O3, because this one canceled and that one canceled. So that's a pretty simple equation to get done. You just have to be able to identify it and set it up. So that's an easy one step. The reason this took so much work was to explain why that all got set up.